Right, so we want to prove by induction the following. So off we go and we do our usual. We do Pn and we just repeat our sentence. 1 plus or to the power of n is bigger than or equal to 1 plus n or. And then just be careful, just keeping in mind we have a restriction. Well, n is not restricted really, it's just part of the natural. So it's kind of our usual. And then the or has to be bigger than 1. So we just kind of bear that in mind. Okay, so we start with prove P of. Now this time I can go back to using 1. The reason I can use 1 is because it's natural number. So off we go and we fill in 1 plus or to the power of 1. And by the way, it's only n I'm filling in for, okay? 1 plus 1 times or. Now, that becomes 1 plus or is bigger than or equal to 1 plus or. Now, is that true? Well, that is true because it says bigger than or equal to. In this case, it's equals to. So they basically, therefore, that is true. So tick correct, and it's true. Okay, so now that we've proven it for one number, we're going to assume it for k. So anywhere there was an n, we are now going to replace it with k. So anywhere there was an n, we now replace it with k. This is going to become our assume sentence. Then we move on to the next step, which is prove pk plus 1. So anywhere there was an n, we are now replacing n with k plus 1. So anywhere there was an n, we are putting k plus 1 instead. Now I'm just going to take a little bit easier to read. Okay, so we have all our steps done. And the next stage now is how, so the key question with the inequalities is, how do we change our assume sentence into our prove sentence? So in yellow, I have my assume, and let's put the prove in pink. So the question is, how could I make the yellow into the pink? Now, in order to do that, you would have to understand, I'll just write it on the side, you need to understand that if it's to the power of k plus 1, another way of writing that is that. So you'd really have to know that in your mind to be able to make the yellow into the pink. So now that I've reminded you of that, can we see how we can make the yellow into the pink? All we would have to do is write the yellow and just multiply it by 1 plus or. Now, if you adjust the yellow on the left, you have to adjust the yellow on the right. So what I mean by that is, if we adjust the yellow to do multiply by 1 plus or, then we have to multiply this by 1 plus or as well. Otherwise, we're messing with the actual maths, we're messing with the inequality. So now that I've done that, I'm just going to rewrite it to kind of look like the pink, okay? And then I'm just going to tidy up this. So 1 by 1 is 1, 1 by or is 1 or, and then k or by 1 is k or, and then k or by or is k or squared. Now, we've changed the assume into the proof. And then I'm going to change my pen again. So I am changing to write my true if and true as. So I'm going to say this is true if my adjusted, sorry, let's change the color. So it is true if my adjusted, so true if my adjusted one, my adjusted assume is bigger than my prove line. So I'll just say that again. So what I'm doing is I'm taking the adjusted assume. So this is what I call my adjusted assume. So I'm taking the adjusted assume and seeing if that is bigger than what was originally in my proof. Now, that is true if. Now, when I look at this sentence...
Apologies for the interruption, but can Joe McGill, second year, please come to the front office with his bag? Thank you.
So I can actually see that this is going to be true because do you notice that this bit is the same as this bit? So all you're doing is adding on a KR squared. So that is going to be true. Why? So it's true if, but it's true as, well, why is it true? Because K is, so if you go back to our conditions, K, and so K is positive and R is positive. In fact, bigger than 1. Then, and R is bigger than 1. So if no matter what K is, so let's say K was 2 and R was 2, we're obviously going to get a bigger result on the left than we are on the right. Does that make sense? So usually then you can fill it in, sorry, if you want, if you just want to see it in action, but I think this is such an obvious one because you've an extra bit added in that's clearly positive. So we just generally repeat the last black sentence because remember, this is what we want. If P of K implies that Pn is an